Hi friends, welcome to my YouTube channel. Friends, in this video we will study the series and parallel combination of resistance. Okay, so see, this is in this three resistances are connected in series, and here three resistances are connected in parallel. So when resistance are connected in series, then current through all these three resistors is same, means IR1 is equals to IR2 is equals to IR3. Okay, but when resistances are connected in series, then voltage is different across each resistor. So if I have to find the voltage drop across resistance R1, then it is equals to 1 upon R1 upon R1 plus R2 plus R3 into voltage V. It means voltage distribution across these resistors is in ratio of their resistance. Okay. Similarly, VR2 is equals to R2 upon R1 plus R2 plus R3 into V. Similarly, VR3 is equals to R3 upon R1 plus R2 plus R3 into V. So this is the voltage drop across all the resistors. Now what is the equivalent resistance in series? We can write equivalent resistance Req is equals to R1 plus R2 plus R3. So simply in series resistance add up. Okay. So when suppose n number of okay same resistors are connected in series, this is n number. Okay, then total equivalent resistance is simply equals to nr. Okay, and one more interesting thing about the resistance in series is that equivalent resistance is greater than the highest resistance among the resistances connected in series. Okay, it means suppose this 4 ohm, this 8 ohm and this 2 ohm is connected in series. Suppose equivalent resistance here is equals to 8 plus 4, 12 plus 2, 10. Okay, so we can see that equivalent resistance is greater than the highest resistance, that is 8 ohm. Okay, so here equivalent resistance is greater than the maximum resistance in the circuit. So these are the points about the resistors connected in series. Okay, now see resistances connected in parallel. When resistors are connected in parallel, then voltage across each resistor is same. Okay, so what is voltage across this resistance R1? VR1 is equals to VR2 is equals to VR3, that is equals to V. Okay, but the current will divide. Suppose here current I is I, then this current I will divide among the resistors in the inverse ratio of their resistances. Okay, suppose this is R1 and this is R2. Okay, and here current is I, then IR1 will be equals to R2 upon R1 plus R2. Okay, and IR2 is equals to R1 upon R1 plus R2. It means that current is divided among these two resistors in the inverse ratio of their resistance, and equivalent resistance is given by, suppose for this circuit, how we find the equivalent resistance? That is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, so here I tell you one more important concept, that suppose if n number of resistors having same resistance R, okay, are connected in parallel, then in that case equivalent resistance is equals to R by N. Okay, here equivalent resistance was NR and here equivalent resistance is R by N. This is another concept. And here one more important point is equivalent resistance is less than the smallest resistance in the circuit. It means suppose this is 2 ohm, this is 4 ohm, and this is 6 ohm. These three resistances are connected in parallel. Then equivalent resistance will be less than the smallest resistance in the parallel, that is 2 ohm. Okay, here smallest resistance in parallel is 2 ohm, so equivalent resistance will be less than this 2 ohm resistor. So this is the concept of series and parallel combination of resistors. In series, current is same and voltage among the resistors is different. Okay, and the voltage is distributed among the resistances in the direct ratio of their resistance. Okay, and equivalent resistance is simply equals to R1 plus R2 plus R3. When n number of same resistances R are connected in series, then equivalent resistance is equals to NR, and equivalent resistance is greater than the maximum resistance in the circuit. And when resistors are connected in parallel, then voltage across each resistor is same. Okay, and current is distributed among the resistors in the inverse ratio of their resistance. Okay, and equivalent resistance is given by, that is equals to 1 upon Req is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. In this way we can calculate the equivalent resistance, and equivalent resistance is less than the minimum resistance connected in parallel. Okay, so this is important. Now suppose if equal resistors of resistance R are connected in parallel and number of resistors connected in parallel are n, then equivalent resistance is given by simply R by N. Okay, so this is the concept of series and parallel combination of resistors. I hope you understand this. Thank you. Jai Shri Ram.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.